All righty, let me do the stop share here, get myself on full screen. Yep, very popular man there. All righty. Well, good morning, everybody. My name is Tony Salas. Mark is down there on the big screen. He's the highlighter. I'm the little guy. Hopefully, you can all hear me. If you can't hear me, please put a message up there. I do have your microphones. I should have you all muted. Uh, Mark and we got together. Mark, I guess you can add. I guess Mark and I will be doing a chat back and forth here, talking about EV. Mark and I met back at a CAT conference, correct, Mark? And
Yes,
at
several years ago.
California
Yep.
Automotive Teachers Conference in California, we met a while ago. And in this case, we started chatting away, and I was there sitting there. I'm the diesel guy that was doing diesel, but at these CAT conferences, I was doing contract, or I am doing contract work for ATEC. And in that point, I was discussing with them and watching all the different EV presentations. So, from a community college, high school perspective, what's going on out there, it was pretty interesting what is being offered at those levels in terms of EV training. The thing is, last time that I was there with them, we were up in Woodland Hills. And in this case, we were talking about, what's going on with EV. But then I started asking a few other instructors too, as well, is that, okay, everybody's teaching EV at their level. And in this case, my question was, how are the people doing with their electrical fundamentals? In other words, understanding electrical fundamentals. And in this case, a lot of them say, well, yeah, they need help. So we're all excited about teaching EV. And you can see Mark, he's going to be dazzling you with his stuff about it. However, though, and Mark can agree, and Mark pitch in here in a second if you like, and that is, if you don't have an understanding about the basics of circuits and series and parallel and capacitors and so on, those are the items that we teach in EL1 and EL2. And in this case, you're going to be a little lost. And when we're doing high voltages, that's going to be another thing too as well. So therefore, if even though I know that most of my audience has been diesel applications, and we've struggled with you guys about getting EV training, and what was the old line I've been saying for a long time, that as a training provider, the hardest class to sell, yet the most needed, is electrical. I can't sell electrical because A, they don't think it's important, or B, they just feel they can't learn it. So therefore, we're in a new evolution. We see these EV vehicles and they're coming on quick. I'll be honest with you. We have a Model 3. We have a Model 3 Tesla. So therefore, it's pretty impressive the way it works. Now, if you're one of those guys, there's diesel guys that says, diesel all the way. Don't worry, diesel is going to be around for a long time. So therefore, EV is just complementing the transportation industry. There are good and bad things we could all talk about, but then we could talk about the good and bad things about diesel as well. So we're not here to actually put down EV. We're here to actually help you out in understanding with it. So, like you, those of you that are in the diesel industry that saw my mass email, please note I'm like you. In other words, EV is new. We got an EV vehicle, and the thing is, we don't, have a complete understanding what's going on with EV. But then there's people that specialize or been working with these, such as Mark right there. So, Mark, before I continue talking more, why don't you introduce yourself and tell us what you do and what everything about you?
Yeah, absolutely. Thanks, Tony. I've been in I come from automotive background. So on the heavy duty side, everything is just going to be bigger, pretty much. But I've been in automotive, worked in new cars, used cars, parts, machine shop, junkyards. So I've got quite a broad perspective there. Along the way, I did manage to go to college and get a degree in the process. And so I'm currently working with ED West. We're a conversion company out of Southern California. And then I teach at I've taught community college since 2006. And then I do different training events like this. So, yeah, as Tony said, yeah, electrical is going to be a huge, you're definitely going to need to understand electrical. And with the EVs, the higher voltage is going to create some safety issues, but I'm gonna cover some of that as we go along here. I want you to respect the high voltage, but not be afraid of it. So all of the systems that you're working on already, they're going to be very similar. The only thing that's changing actually is just the drivetrain portion of it is going to be higher voltage. So, and as Tony said too, it's not that diesel is going away. It's not that we're going to just flip the switch and today diesel's here and tomorrow it's gone. It'll be a transition over probably 20 or 30 years realistically. So I think Tony, you have
That is pretty much it. So Mark came up to me at the CAT conference there in Woodland Hills, and he says, "Hey, let's get a class together." I said, "Well, before we do a class together, we got to get these guys that are diesel to get liking or understanding that they need to have a good electrical fundamental or basis of understanding it." So that's why we're here. We're giving you this free webinar or podcast, whatever you want to call it. And in this case, we're here to discuss about what is going on. So therefore, Mark, I'm going to take over here for a second with my PowerPoint, and let me switch over here, and let's get going. So as Mark was saying, yes, we need to have a good fundamental. Mark and I are going to be talking back and forth here to help you out. Obviously, is you have to have a starting point. So it kind of, when I look at this EV stuff, for those of you that are not good with electrical and yet, you need to understand electrical, I kind of remember it as when they used to tell me about playing golf. They said, Tony, don't start playing golf with your buddies because I get a lot of parts suppliers and stuff that invite me to go golfing and stuff. And in this case, I'm like, you know, it's like, why don't I just go play golf with the guys? Just to swing it away. He says, no, because you're going to learn bad habits. So therefore, same thing with EV. If you're starting out with EV, in this case, it is a good idea to keep in mind that you may want to start fresh and understanding from the fundamentals all the way to the advanced stuff that Mark will cover, because Mark's going to cover pretty much on his trainer, what is going on with EV. So with that said, it all starts with understanding where you're at. Now, some of you, probably are weak at electrical, but the fact that you're here, the fact that you're me watching the recording is saying something that you are aware this is happening. So therefore, you have to have an understanding of electricity. Now, please note, in our industry, when I look at other, forums and, I see different groups on Facebook and so on, I kind of dislike the fact that there are instructors trying to sell you that you don't need to know the movement of electrons kind of stuff. But I'm one of those believers is that isn't it fun to work on something when you know how it works? So therefore, as I saw Mark do his presentations at a different conference, and I see other EV presentations and classes and so on, one of the things I see is like, well, hello, we already have that, already do that. Electricity is electricity. As a matter of fact, I've been cleaning out my garage and getting rid of stuff, and I found my old GM book right here. And in this case, it's like there's the cover right there of Ohm's law, and in this case, what I'm trying to get at is, there's nothing new. If you've already taken electrical, at least an EL1 type of thing or an electrical 2 type of thing, you're already, got a good foundation. But if you haven't grasped that, then we need to have a talk about this. So when we talk about electrical training, I know I just checked on IETN, I get the emails. And the problem that I'm seeing, first of all, is that, like I said, you want to start playing this game fresh and clean. And what I mean by that is, do you understand pretty much everything from what is electricity all the way to what we see in bipolar transistors? So therefore, that is all part of EL1 and EL2 class that I've been offering and other people have been offering. However, when people want to bypass the movement of electrons and the elements, you're kind of selling yourself short. And in this case, you're not going to have you're not going to have a good understanding of what's going on with EV. So once again, as Mark's going to talk about different components that are on EV system, please note that it is imperative that you have a good foundation. So therefore, what are the discussions on those items I've got? Well, first of all, the meter use. Mark's going to talk about the meters that are now available for EV testing and what are you going to be testing, because obviously you need to do that. Because one of the basic things that I've seen EV presentations present on is, okay, you got a VEV vehicle comes in. The fact is that it's got to be charged. So therefore, if it has a very low charge, the question begs, is it getting a charge? So there is a connector that goes on a vehicle, which Mark will talk about the various different types. But in this case, it starts from one of those basics. So the diagnostics are very similar to that what we see with diesels. But then in knowing how the circuits are laid out and how they work, that's your other challenge. So we talk about voltage, we talk about amperage, we talk about the resistance and Ohm's law, which I'll get into it in a second. But in this case, you have to have an understanding of those, those items. So where are you with electricity? Let's be fair. So one of the things I'm developing right now because of, my relationship now with Mark is I've been working with a program to make an electrical assessment of where you're at. Now, it's not to see how stupid you are, it's just to know what your weaknesses are and what you need to focus on. And let me tell you, I've taken a few electrical training and electrical courses and also quizzes. And let me tell you, I had to brush up on some stuff also as well. So, therefore, when you're dealing with EV, you got low voltage and high voltage circuits. How high of a voltage can we get, Mark? What is the highest
We're
voltage we
seeing
see?
upwards of 800 volts on some systems now.
So therefore, we see 800 volts, exactly. So therefore, we're seeing 800 volts. We're seeing a 12 volt. And then if you've been watching everything that's been going on with the Cybertruck being released, it's got a 48 volt system too as well. So in this case, we need to know what voltage is. So in this case, we're talking about, very low voltage or very high voltage. So that 12 volt mentality is going bye-bye. In this case, we still got 12 volt systems in there, but in this case, we see the high voltage taking place. And then comes the killer, the amperage, which Mark's going to shock you with a little demonstration here of I guess I won't give it away from Mark, but in this case, he's going to give you, but amperage is the big thing. So therefore, that is the flow of current that goes in the circuits. So again, like Mark says, we need to learn how to respect the electricity as we're working with these vehicles. But then in understanding why a circuit is doing and when you're diagnosing circuits, because remember, Mark told you he does, conversions too as well. And his challenges with his Honda has been interesting. And he had to figure out stuff such as, something as simple as a fuse blowing. But the fuses are not exactly small little fuses anymore. We're talking about some mega fuses that we're talking about here. But it all comes back to the characteristics of circuits. Why are circuits laid out the way they act? So when you're doing troubleshooting, when you're doing diagnostics of an EV vehicle, it's going to require you to understand those series and parallel circuits, how it's laid out. So as we talk about in diesel about the battery, then from the battery we go to power distribution, which goes to a starter, then it goes to a fuse box, right? We have to understand that what comes out of a electric or EV vehicle. But if you still haven't grasped it on an EV vehicle, we're going to have problems. So one of the key things we do in EL2, and I got a few guys here that are logged in. I see some names that have taken my EL2. And one of the things I make them do is actually towards the end of the course is you're going to tell me how the rectification circuit works on a charging system. Now let's get something clear. Alternator's been around since what year? 1974, somewhere around there. And in this case, I challenge guys to understand how a charger or alternator slash generator works, right? Then we got motors, we got starter motors. But then when you look at today's motors, you got permanent magnets, you got inductive motors, you got various different, those two different types. So in this case, it all goes back to alternators, generators. So do you understand that? Because what I make the guys in EL2 do is tell me what a diode is doing, how it's forward biased and reverse biased in the circuit, and tell me how it changes that AC to DC. So in this case, we have AC to DC, but we could have DC to AC too as well. So there's something as a converter and inverters. So we have to understand that too as well. So again, those are the fundamentals we've been teaching in EL1, EL2. Not that I'm trying to repeat myself, but again, if you don't understand how a alternator does the rectification, how the induction system works from the rotating rotor to the stator, which in turn creates the AC out of the three-phase circuit, you know, we're going to be a little lost as well. So I'm not trying to turn you off. I'm trying to encourage you, take it on, learn it, because that's the way I'm doing. Let me tell you, because I could stay with diesel, but I'm intrigued with something new in learning the EV just like you are. So therefore, starters, motors, understanding how a diode works, and that's very important. But then Mark's going to show you some capacitors as well. So do we understand how these capacitors work? Some of us call capacitors condensers. We also have a low voltage switch and so on. But when I was watching Mark, and I was telling Mark about this a while back, I don't know, Mark, if you remember, but I was watching Mark teach his presentation. And in this case, Mark was talking about what we like to call a relay, which is a high voltage cutout switch. And in this case, you got a low current circuit operating a high current circuit. And he's covering that. And the way I look at it from my understanding, and Mark calls it different because, you know, he's the EV guy, is that it's just a big glorified, you know, like an old four starter solenoid, you know. And in this case, Mark was literally spending half an hour explaining to these guys how that worked. And I was a little kind of miffed for the simple fact that, guys, it's just a solenoid, it's a relay. You ought to understand the principles and operation of this. But then when I was over at presentations that, you know, we were teaching with Mark, you know, I was in a separate session. I'm talking about relays, and I literally spent, you know, 45 minutes talking about relays. And, you know, if you watch my webinar that was Lucas sponsored, you know, last week, you probably saw that too, where I was talking about relays. So guys, those are fundamentals. So why am I here with Mark? Is to tell you I'm the fundamental guy. He's the advanced EV guy, you know, because he's more experienced with it. In time, I hope to become experienced too as well. But what I'm trying to say is you cannot succeed because as you look at the my slide right here, you know, Ohm's law. You know, guys say, well, why do I have to do Ohm's law? Well, because there's a relationship between voltage, amperage, and resistance, and then there's the power formula. And the power formula is pretty interesting because as you watch, for example, the Cybertruck thing, you know, you're going to see they're using 48 volts. But, you know, when you look at a component that's going to use so much power, you're going to notice it's the wattage, right? And watts is amps times volts. So in this case, if the voltage rises, the amperage drops and it still meets the wattage requirement. So therefore, you know, by going with more volts and less amperage, the wiring can be smaller, you know. So therefore, we all understand or should understand that for a given circuit, you're going to have so much amperage that's actually being drawn or pulled through the circuit. So if we lower that voltage, we can actually raise the amperage or vice versa. The voltage goes up, the amperage goes down. And we've been talking about this in starting circuits. So therefore, that's something to understand. And just to even tell you, and let's be straight up front here, you know, I just got a call from a shop owner. I'm doing a class. I'm going to a class, a shop next month in January. I'm spending 4 days there. And in this case, in those 4 days, he asked me to cover how to diagnose a starter in an alternator. So guys, if you're in that same boat, you know, Jesus, let's get some training on this. So hopefully Mark is going to blow you away on some of the stuff that he's going to cover, but it is important for you to understand, you know, what causes that fuse to burn and what's going on there. So, but then there's AC and DC. When we talk about RMS, you know, a lot of guys, as I look at the books, you know, and I've gotten a lot of EV books already, and in this case, I look at presentation, and guys talk about RMS. What is RMS? Root means square, right? And in this case, we don't understand what RMS. And many of your meters on the top, like this one, is my Fluke 87 right here, you know, you can look very closely there. It actually says it's a true RMS reader. I don't know if you can see it right there, true RMS. So therefore, what is RMS? You know, and therefore we also have AC. Do we understand how to measure AC? That's why we were talking about scopes and getting to learn scopes too as well, because we're talking about peak to peak voltage, and also AC RMS. So that's another thing. You know, and then there's bipolar transistors. You know, when you look at bipolar transistors, those are the basic because in common rail technology, we're using MOSFETs, field effect transistors. So what is a transistor? It's an electronic switch. It's kind of like a electronic relay in itself, and they're using a whole slew of them that you can see, you know, in an EV vehicle. So very important to understand. So therefore, it all starts off with the beginnings. That beginnings is understand how voltage is developed. So for the longest time, we've been using lead acid batteries, and now we're seeing the lithium and all the different types of lithiums that I can't even memorize yet. But even in the RV industry, you know, they're pushing the big time the lithium battery. So it's not just a fundamental thing about lead acid battery, but also learning the characteristics of lithium batteries. So therefore, we're going to see a different type of battery, obviously in an EV vehicle. But again, you have to understand what is the charging characteristics, how it works, and how it's actually managed, right? So, you know, we have a Model 3 Tesla in the family, and one thing that, you know, they decided, my family member decided to drive to Southern California, and the thing is they're coming back in 115-degree heat. You know, I knew the draw is going to be significant on the battery because they're running the cooling system for the system, not to mention the AC air conditioning in the vehicle as well. So therefore, everything had to be cool. So I knew the draw is higher. So therefore, I told, I mean, this is the way you got to do it. This is how you got to work. So when you have everything I could see on a vehicle on a Bluetooth enabled stuff, it's pretty amazing where the technology is at. So therefore, key things to keep in mind is, where are you with electricity? And if you want an assessment, one of the things we're going to be offering here at Powertrain Training along with Mark, and Mark's going to help me validate it. And by the way, Mark, you just volunteered for that, by the way, I forgot to tell you. But
Okay.
anyways, we need to evaluate where you are with that. So it would be nice to set a good foundation. I am not going to cater to what you think you can learn, what you think you can't learn. And what I'm trying to say by that, I'm not trying to be mean, is that I want you to have a good understanding on where you are with electricity so you know how these things work so you can actually take on the EV. And if you've been watching your TikToks and you've been watching your Facebooks, there's many companies out there that are trying. There's that one guy that's actually the logging guy that's actually, doing pretty much running a cat diesel, running a hybrid version of an EV vehicle. And, his horsepower and torque are looking impressive and he's got investors there. So therefore, there's also the hybrid side of things too as well. So therefore, there's EV, there's hybrid, but it all is encompassed together. So the internal combustion engine is still being used. So the bottom line is, again, I'm going to let Mark take over here in a second, but what I want you to understand is, once again, get a good foundation because like those instructors that I discussed over at that conference, and they're teaching away at all the different EVs out there. If you don't have a good electrical foundation, we're going to be, first of all, safety item. And the second thing is knowing how things work so you can become a better diagnostic technician. So I know a lot of you have come through the ranks in your diesel repair, diesel drive-in shops. You come in through, you started off as doing shop cleaning, then you went to oil changes, and you moved up, okay, with no education. So therefore, with the internet and so many programs out there and YouTube and everything, it's a sin if you don't learn it very well. So again, let's get a good foundation on EV. So Mark, we're going to let you take over it. You can go to, I'm going to stop my video and you're going to go full tilt boogie there. I'm going to stop the share too. So let me stop my share there. And there's Mark. And in this case, Mark's going to talk about the EV. And if you don't mind, Mark, I may ask a few questions while you're going down. And if you do have questions, click on the chat and feel free to ask Mark any questions you have. Or if you have something to ask me, by all means. Mark?
All right, perfect. So I'm assuming I'm on full screen there. Is that how everybody's seeing
Yes, sir.
there?
You're full screen.
Okay, perfect. All right, so I'm going to I'm going to take the webcam and I'm going to show some of the actual components. So the camera may get a little shaky here. We'll do this best we can, but I want to start off. And I have a short PowerPoint as well, but I really want to do more actual hands-on with some of the components that I have here in front of me. So I'm going to start off by doing an introduction to the EV components, and so we'll see how this is going to go here. So Tony, if you can give me feedback, because I won't be able to see as I'm doing the camera as I'm showing
I will
the.
tell you, my friend. I will tell you.
So, all right. So I'm told if I hold the camera slow, I have to hold the camera for this. So Tony, how's that looking?
That looks fine.
Good. Okay. So on electric vehicles, I like to start out with you really have the big three. And so let's talk about those first. So the first item on the big three is going to be your high voltage battery. So this particular one that we're looking at here, this is
Mark, Mark, let me pause you there for a minute. They're saying they're not seeing you full screen. Did you turn off your PowerPoint?
they're not seeing me
Oh,
full.
let me stop. Oh, that's me there. Okay, let me stop. Hold on just a minute. There we go. Okay, now, Mark, you need to go on your video.
Okay, I'm seeing my webcam, but what are you seeing on my end, Tony?
Only my picture. Well, I can see you, but I'm trying to give you. No, you're good. My video stopped. Um, hold on. Okay, I did.
All right, so
Okay, is Mark
let's.
there? Try it.
I'm here. Can you hear me?
All right, so can you all see him now full screen? Let me give me some feedback, guys. Let me know if you guys can see him full screen now.
So they should be. I have the camera over the training bench.
I'm gonna
And
switch it over to host for you there. Okay. Okay, you should be able to see full screen now.
okay, so let's try again here. So Tony, you should be able to see. I thought the same thing that they were. So we should be looking at the high voltage battery right now.
Yep.
Good. Okay. All right, perfect. So this particular one is 100 volts. This is a popular one that we use in conversions that you would see on a full electric vehicle. These are usually they're upwards of around 400 volts. Seems to be a popular number. In the diesel world, we are likely going to see 800 volts. So the next component would be our electric motor. So we're using, the popular choice is going to be an AC permanent magnet, 3-phase brushless motor. So that's going to be that guy there. And then we're going to use an inverter to change the DC battery voltage to the AC that the motor will need. We're going to have, we talked about my hands in here. So this is the high voltage fuse. So this is a 600 amp fuse. That was one that I was having issues with. That it was I had a problem that that fuse was blowing, and so that'll go when it goes off. It sounds like an M80 going off. So we have a maintenance switch here. So those are the main three: the battery, the motor, and the inverter. But then up top here, we're going to take a look at, is that still coming through okay, Tony?
I think so. Some people are saying because you, according to on my screen, you're full screen. So, and I've already turned off mine, and I've made you the speaker already. So,
Okay. Well, I'll just keep rolling here, assuming that we're okay until you tell me
mhm.
otherwise. So we're going to have a high voltage junction box. So that's going to be this gray box here. So these are going to be some contactors. You're going to have some low current but high voltage fuses for your heater, your charger, some of your other circuits. And then you're going to have on an electric vehicle, you're going to have a regular 12 volt system, just like you're already familiar with. And so that's going to be this group here. So you're going to have, so these are just regular 12 volt fuses here. And so we have one that's constant and one that's switched. And then we're going to have this component here is going to be our DC-DC converter. That is going to perform the function of your alternator. And that's going to charge up your 12 volt battery, which really what that's doing is just it's robbing power from the high voltage battery to charge the low voltage battery. And then over in this group here, this is going to be our charging group. And these are going to be the components that we're going to use to plug into the wall to charge up the high voltage battery. So we will also have, we'll touch on, so this is going to be the battery management system here. We won't, well, we'll touch on that just a little bit. That can get into a whole lengthy discussion just on that in itself. And then we have some driver feedback controls here. We're going to have our battery gas gauge, if you will, in your direction, standard key switch, and throttle. So with that, I'm going to attempt to put the camera back on here. So bear with me just a moment. And
Hey, Mark.
are there any questions in the chat?
Yeah. Do you have a view setting on the top right of your computer screen?
A view?
It says view on the top right of your computer screen.
Yes.
Click on it, and You make sure your speaker.
I'm speaker.
Okay, so your speaker, yeah. Okay, just making sure because according to this, you should be fine.
Okay.
Also, go to full screen too as well.
Full screen. Okay.
Okay,
Is that better?
it should be.
We're good. Okay.
All right. Hopefully, you can all see.
Okay. All right. With that, so that kind of covers the components that will be in play. There again, other than those, the rest of the truck car is just a regular car that you're already familiar with. All the wipers, the lights, everything there. So I want to touch on some of the safety items. I don't want to get too involved. Sometimes the safety just goes overboard. I don't want to underestimate the safety, but we need to touch on it just a little bit, just so that we've covered it. So when you're working primarily inside the battery box, um, you're gonna want to have high voltage gloves. That was noisy there. So you're gonna have special. These are class 0 gloves, and so these are some line. So you end up with a couple different sets of gloves here that you're going to be wearing at the same time. So we're sharing with how it's supposed to work. So essentially, you're going to put the cotton gloves on first, then you will put the rubber gloves on top of those, and then you put the leather gloves on top of the rubber gloves. So you would be wearing all three of these, which would give you pretty much 0 dexterity, and that's what they want you to do. Um, okay, so we touched on that. So what I want to take, so the main risks that you're going to have are if you're going to either get shocked from the battery voltage or if you're going to create a short circuit. Okay, so and what ultimately what you really want to do is you want to learn to trust your meter, that's where Tony does a great job of teaching how to use the meter. And so if you're sure before you're working on a circuit that you've tested to make sure that it's not live, or if it is live that you're aware of that, then that's really your first line of defense. So I do want to demonstrate what it would look like in the event that you short circuit um, something in the high voltage system. So we're going to attempt to do this now. I'm going to move the camera. Hopefully you're still able to see. So let's go over to here. Okay. Tony, how does that look?
Fine. What we're looking at is the wire that you see he's got taped down there right there. So,
Okay. So what we have, let me describe what you're seeing. So what we have here is this is a regular 12-volt fuse. And I have it set up on the top of the table here that I'm going to be sending 100 volts through a regular 12-volt fuse. And it may be too fast for the camera, but hopefully you'll be able to at least hear it. And we may do it a couple times. But for me, this is really the biggest risk that you're going to face is if you get a wrench across two high voltage lines. It's a different experience than if you short circuit something on a 12-volt system. So when you short circuit something that's high voltage, what's going to happen is the metal is going to plasma. And I didn't really understand what that meant until I saw it a couple times. And so when the metal plasmas, it will just vaporize. And so that's what we're going to attempt to watch right now. So you watch the screen there, and you guys are welcome to put in the chat. I think the chat might be the easiest way to let Tony know what's working and what isn't, so we can adjust on the fly here. Okay, so I'm going to go ahead and I'll do a countdown, and then we may do this again. We'll see how it goes here. So we're going to go 1, 2, 3. Okay, so Tony, how did that look from what you saw?
the sound beat the video.
The sound beat the video. Okay.
Yeah.
So yeah. So and then is this, are you able to see this on the camera?
Yep.
Okay. So yeah, so the fuse, there we go. Yeah. So the fuse just vaporized. So you wouldn't see a normal 12 volt when it blows. It doesn't look that intense. Do we want to see it again? Was that beneficial or not?
Well, it showed a flash of light, that's for sure.
Okay, let's take a look at one more. And because, like I say, for me, this is the main thing you need to be aware of that you don't do. Is it still showing up in the camera? Okay, so here we go. We're going to do the same thing one more time. And we're going to go 1, 2, 3. Okay. So you can see actually, I don't know if you can see it in the camera, the stain on the floor. So that's 100 volts going through a 12 volt fuse. Okay. Let's take okay, I think I may, do I want to, let's go, I'm going to switch over now to, I have a short PowerPoint. Let's go to that. And let me know if, okay, so can somebody in the chat, can you let us know if you're able to see my screen now? And then Tony, if you can let me know.
Yep.
Okay, we're
Brock
good.
is telling us he can see it, and I can see it too.
Okay, perfect. Okay, so these are the things that I wanted to cover today. So we covered the overview of the EV components. We touched on the safety. I want to get into some equipment. We're going to go through a power flow and how the electricity flows through the system. I want to do a quick start wiring. It's one of my favorite sections. I'll draw that on the board. And then we need to talk about voltage isolation and some charging. So I have a couple slides here. I'm going to toggle back and forth. Okay, so these were actually, let's go through some of these here. So this is what we were looking at on the camera, and I'm not sure if you were able to see it. If you weren't, this should be a better shot of it, I think. So you have on your right-hand side, so the clear box there, that's going to be your junction box where you're going to do your high voltage switching. So on electric vehicles, sometimes that's inside the battery box, and sometimes it's separate. So Tesla actually has some of those components inside and outside, but they're all contained in the box. But whether they're in the entire battery box, and then up at the top of the screen there, you have the DC-DC converter. That's going to be act as your alternator, and then in the upper left-hand corner, that was all of your charging components. All right. And then this was what we were looking at on the bottom shelf there. It's a better shot of your, so we're looking at the battery box. So that's going to be in orange there. So in a factory electric vehicle, that's generally going to take up the entire floor of the car. Usually the battery box is just a little bit smaller than a twin bed mattress. They can weigh upwards of 1,200 pounds. And then on the right-hand side, then you're looking at there's the black box here. That's going to be your inverter. That's the one that's going to take care of switching the DC from the battery to the AC that the motor will use. And then in behind there is a red that's going to be your 12 volt battery, and those can be anywhere in the vehicle, just like on a regular car. It just depends on where the manufacturer finds a spot to put it. And then on the bottom is your the electric motor. Okay.
Now, Mark, this so they can understand. This is a Tesla system on a cart, correct?
This particular one is a Hyper 9. We're using Tesla batteries. So inside that battery box that you're looking at, those are actual Tesla modules. There's actually what you're looking at there is you're looking at 4 modules that are 25 volts each. So if we connect, that's what we needed to touch on, the series and parallel. So if I connect 4 batteries in series that are 25 volts each, that's going to give me my 100 volts. So in a Tesla, they're actually using 16 of those modules, and so they're ending up with which they're driven for more performance and long range. But yeah, so it takes up the entire floor of the car. And then the electric motor that you're seeing there in the picture, that one there, that's what's called a Hyper 9, and that's a purpose-built. They're new motors that are purpose-built for the conversion market. If you go to any kind of car show that has converted vehicles, there's 90% chance that's what we're going to find under the hood. Although we do have Tesla motors that we are doing Tesla swaps, so that's becoming more popular. We've just reverse engineered the computer programming, and so you will see an actual Tesla motor in, say a Corvette, or we're doing retrofitting them into trucks now, like regular pickup trucks. Okay. Did you have anything else on that, Tony, while I was on that slide?
Nope, we're good. I'm good. Anybody else have questions, feel type it in on the chat.
Okay. All right, so here was some of your safety stuff. So that was the gloves that we looked at already. Definitely, if you're working inside the battery box, then you're going to want to have some eye protection on, because that's so pretty much you can isolate the high voltage to the battery box, but once you're inside the battery box, you're just straight up working on live wires. So like in other words, if you're working on the motor or the inverter or in the junction box, once you disconnect the main battery box, all those other systems are safe to work on once you've verified that there's no voltage present. So a couple other things here worth noting. So as you hopefully saw enough on when I short circuited the fuse, you definitely want to have an escape route. So when you're working underneath the hood, in the event that you short a wrench across something, you need to be able to have a way of getting away. So we always recommend don't work with your back to the wall. And then you see all this also there, don't work alone. So that would primarily be when you're working on the high voltage part of the system. Make sure that there's somebody else there to come to your aid if you need. So we put in the fire extinguisher. So these primarily right now we're using lithium-ion batteries. You have seen on the news where anytime a Tesla goes up in flames, that seems to make the news. They're still safer than gas cars, from what I understand. But essentially, when the batteries do, and I'll say catch fire, actually what happens is it's a chemical reaction. And it's more of a bubbling, and then it'll catch whatever on fire around it, upholstery and whatever. But you're not really going to be able to put the batteries out, because it would be like putting out a chemical reaction. So really what they do is they just douse it with water. And supposedly it takes like 10 times the amount of water to put out a lithium fire. But don't think that a single fire extinguisher is going to put it out. Generally, if a car goes up in flames, what you try to do is just push it outside and you just let it burn out. So the other thing that they have there is that they have a rescue hook. So this was kind of big early on, where everybody was worried, oh my goodness, you're going to get electrocuted. And let me kind of break down. So when you're working on the AC side of the system, so that would be the alternating current side of the system. That would be from the inverter to the motor, which essentially those are just going to be 3 main wires. The other part of an electric vehicle that's going to have AC is on the charging side, where we plug in, and I'll get into that at the end. But when you plug into the car, you're going to have AC that's coming from the building. So when you get a hold of AC, that's where you're going to get electrocuted, and that's where you see where people grab a hold of the line and they can't let go because it paralyzes the muscles. So that's definitely something to be aware of. But as far as the DC side, DC, as I understand, I'm not the expert, but that is so I have been shocked many times on DC. And so when you're shocked, you just feel it like when you grab a hold of a spark plug wire, which is, this audience, you wouldn't necessarily be doing that on diesel trucks. I get that. But if you've ever grabbed a hold of a spark plug wire, that's the same sensation that you feel. So, for as far as for ASE purposes, if you're testing with ASE, which I do recommend, they have a special safety certification now for working on high voltage vehicles. And so they do touch on the rescue hook, but more of what they're emphasizing now is what they call a non-grab body tackle, where realistically, if somebody is getting electrocuted, the time that it's going to take you to run and grab a rescue hook and actually hook it around them and pull them away is just not really realistic. And so what they want you to do is just basically push them off of the circuit. Like I said, the only time you would have that situation is if you're on the AC side of the circuit. Okay, moving right along here. Not scrolling. Here we go. Okay, so isolating our high voltage. So every system is going to have a way of isolating the voltage to the battery box. So you can see on the screen there, so you have a couple of different methods that they'll do that. Usually it's going to be some sort of plug that's going to disconnect at the battery box itself. So I won't go through each one of those, but you can take a look at those. So the newest one here, I don't know if you can see my cursor, but so Tesla, you see Tesla they use what's called a fireman's loop. And so what that's doing is so on anything over 200 volts, you're going to have a contactor for the negative side and the positive side. And so the theory is the odds of both of those failing in the closed position at the same time is minimal. And so Tesla, they just have the fireman's loop there, and so the rescue personnel, they're trained on where to find that. Usually it's in the front of the car. We call it the frunk now. And they just cut that loop, and then that's just prohibiting the contactors from closing at that point. All right. So tools, let's touch on tools for a second here. So tools, we're going to use a Cat 3 meter. And so the idea with the Cat 3 meter is we have special insulation on the leads and inside the meter itself so that it can handle the high voltage. So you don't want to be using your Harbor Freight meter when you're working on the high voltage system. We'd like to highlight on the picture in the upper left-hand corner there, that one there are two plastic tips that slip over the top of the leads there, so that you just have a very tiny amount. Let me change. I'm going to change screens here to. I'm going to stop sharing for just a second and show this live. And you should be seeing me. Tony, can you talk to me there? Are we seeing me on the camera there?
Yeah, we're looking at you, sir.
Okay. All right. So here we got so this will be your Cat 3 meter. So this is a Fluke. It's one of their lower line ones. So it tells you on here that it's Cat 3. But in addition, you need to have the leads that are also Cat 3. Okay. So if you have a Cat 3 meter, but you're not using test leads, then that kind of doesn't do any good. So this is the main thing that you're going to want here is the tips that go over. Let's see
Yeah, we can see it fine. You're fine.
Okay. All right. So they just slip over like that, and then they click on there, and then all you have then is just at the very top. Then you have a test point. Okay. Because if you're testing a high voltage circuit, and you were to short these together like this in the process of your testing, then it would do the exact same thing that the fuse did earlier for me there. Okay. So then I'm going to show some high voltage tools. So you can buy the fancy high voltage tools. We generally, and I'm not saying we're recommending this, I would recommend get the regular tools. We just wrap them with electric tape. And then another tool that we will, I'll show you a picture of, but I'll just show you while I have the main screen up here, is this tool right here. This is definitely one that you're going to want to get. I use this regularly. So the main feature of this one is the amp clamp portion of itself. So this is Cat 3 rated. It is also, this one will do AC current and DC current. So you can get these on Amazon, find them for about $50. They are worth every penny. So take a note of that and make sure you add that to your list of tools. Okay. I'm going to share my screen again. Let's go here. Share. Okay. So that covers most of what was on there. Let's see what I had next here. So you will, so on the screen, what you're looking at now, so there are a couple of things. We won't necessarily get into CAN sniffing, although a lot of that is something, if you're not familiar with CAN bus systems, you probably should add that to your list of things that you want to get some knowledge on. Off to the left there, it's showing you a thermal camera. Those are a great way. You can get these as apps on your phone, but for testing to see if a component is heating up. Those can be a super handy tool. And then the other one there is a differential probe. And what you need to understand is when you're testing components, if you're testing a high voltage component and you're testing a low voltage component and you're doing a dual trace on a lab scope, you are totally creating an isolation fault in the system. In other words, you're connecting the high voltage and the low voltage through your scope. So that's not something you want to do. So they make a differential probe so that you're able to use a dual trace for those of you guys using scopes. The new Pico scopes, they have that built in, as I understand.
Hey, Mark, what is a CAN
so there were some
sniffer?
of your high voltage.
Hey, Mark, what's a
So
CAN
the
sniffer?
CAN sniffer, yeah. So the CAN sniffer, so we use CAN bus for communication between modules. So it would just be kind of like we have many computers on the car. Instead of running computers or running wires to each computer, you just run 2 wires between the computers, and then they talk to each other over those 2 wires. So with a CAN sniffer, we just tap into those 2 wires. Actually, let me, if I can do this. Yeah, I was going to try. It's taking a long time to move the camera. I'm trying to speed things along here, but so they use 2 twisted pair of wires, and so the CAN sniffer taps into those wires, and then we can read the conversation that's going on.
Okay.
Does that work, Tony?
Yes, sir.
Okay.
Thank you.
All right. Okay, let's talk. Okay, so I want to talk about power flow. So I can get this whole thing there. Perfect. It's not gonna let me. Okay, I'm trying to scroll so you can see the whole thing there. And bear with me just a second. Okay, so let's talk about power flow through the electric vehicle. Okay, I think that should be good. Tony, can you see that on the screen? Okay.
Yes, sir. Everything's, yep.
Okay.
Yes, sir.
Very good. Okay, so you see in the so we start out, let's start with the lower left-hand corner there. So you have the charge port. So that's where we're going to connect to our building. So these are in the United States. These are, we have 2 primary sockets that we're using. So one is called a J1772. The other one is called the NAX. That's going to be the Tesla standard. and that's the one that's quickly taking over. You've seen on the news, Ford and GM and pretty much everybody is adopting that one. So those will be phased in. But so for the moment, there will be, in the United States anyway, there'll be two versions. They make an adapter that you can connect to your cord, so you're able to, with either type of socket, you can use either type of cord. So it's pretty. There's a workaround for it, having two systems right now. It's kind of like the Beta and VHS back in the 80s, but you're able to work around it. So then that's going to go into your high voltage battery charger. Oftentimes people think that the charger is the part that is on the wall, or the part that is at, when you go to a charging station, that's the charger. All that is that's just an expensive extension cord. The actual charger is in the car. And then so you're going to need some charge. You have the charge controller. So that's just going to be the computer that's going to make sure that all goes the way that it's programmed to do. So from the high voltage charger, it's going to go into the contactor box, that's also referred to as a junction box. And then from there, it will charge up your high voltage battery. So that's on the power coming in portion. So when we're adding power to the battery, that's how that part's going to go. Now, so when we're driving the vehicle, then we're going to be taking power from the battery. That's going to go through the junction box. Then the next stop is going to be the inverter. And then the inverter, we said, is going to take care of converting it from DC power and turning that into AC power to run the motor. From the motor, you can see there we're going through a gearbox. And you may be saying, well, wait a minute, I thought if we had an electric vehicle, why do we need a gearbox? Why don't we just connect the electric motor to the wheel? Well, I'm glad you asked. So we are still going to need some gear reduction with an electric vehicle. So the sweet spot tends to be around 8-to-1. So essentially, we would be spinning the motor 8 times for every 1 time that the wheel is going to spin. So that is, you are still going to have a gearbox. We're not going to need to change gears per se. That in a conversion, you can do that. I have that in my Honda, but for factory vehicles, usually it's just there's just a gear reduction, and there's no changing of gears. So, all right, with that, I think I've covered everything there. Unless Tony, if there's any questions that are coming up in the chat, just chime in here and let me know.
No, we just had one guy lose sound, but everybody else has sound here. So.
Oh, okay. So hopefully that's just an isolated issue. Okay. All right. So this was just a series parallel that I threw in just to make sure that we touched on that. But in case, so let's talk on this for a second. So we said that in the example there, we're using 4 Tesla modules at 25 volts each, and so we stack those together in series. That gives us 100 volts. So if we want to increase our available power, I want you to think of the battery as, I like to use the example of a bathtub. And actually, I think I have, I think the next slide has the bathtub on it. But so if I, yeah, so you're going to need a certain amount of electricity that you're going to take with you, right? So if you want to go further, you're going to need essentially a bigger battery, right? Or if you want to, essentially you're carrying a bigger bathtub with you. And you're always going to want to have a certain amount of energy in the battery, but you don't want to overfill the battery. Let's take a look at the next, let's see here. Yeah, I'm skipping ahead there. Yeah, actually, I'm going to go back. Sorry, let me change that thought. Okay, so just understand that. So if we want to go further, okay, one of the common questions is, well, how far? What kind of range do you get? How far can I go on a single charge? If you want to go further, you're going to need to add more battery. Okay, if you're adding more battery, you would add that in parallel, not series. If you wanted to increase your voltage, then you would add them in series. Okay, we'll leave it at that. All right, so next here, all right, so, okay, so I'm gonna take a look at this picture, and actually I was gonna draw it out, but I think I'll just talk to you the picture. So this goes to the quick start. So I call this the quick start for electric vehicles. So one of the things that kind of got me was that you have, you know, the whole system and all this, you know, the charger and the junction box and you know, all this wiring, and it just seems overwhelming. And so I wanted to kind of break it down into its simplest form, which is what you're looking at here. And so this is all you really need to get the motor to spin. Okay, so you can see at the top there. So we've got the high voltage battery. Then we're coming in through the contactor box, through the inverter controller, into the motor. Okay, so those are the four components at the top. That's essentially covering your big three. So the contactor box, that'll either be inside the battery box itself or right there beside it. Okay. So then down below, when you're looking at the wiring schematic, those all plug into the inverter. So the inverter is going to be your main brains of the driving part of an electric vehicle. Okay, so just the motor portion of it. Okay. So if we're looking at the top portion of that, actually, you know, I think I may draw this up. I'm going to switch screens and I'm going to draw it out. So I'm going to stop sharing for just a second here. And okay, so you should be looking at the marker board. Tony?
Yes, sir.
We're good. Okay. All right. So let's do it this way. Okay. So in early life, okay, if life was easy, we would have let's draw a battery over here. So let's do it. So 100 volts. Okay. So in early life, is that showing up on the screen? Okay.
Yes, sir. Yes, sir.
I see the reflection there, but
No, but you're good. We could read 100 volts in the square.
okay. All right, perfect. Okay, so this is going to be this will represent our battery. This is going to be our electric motor over here. And so if this was a DC motor, we would just have one positive and one negative going over to our high voltage battery, right? And so we would have some controls in here to change the speed, but that would all be fine and wonderful. But so DC is not as efficient as AC. Okay, there were some early systems that did use DC. People were using forklift motors and some aircraft generators, and but they weren't efficient. So we have since changed everything over to AC, and pretty much everybody loves AC, and so that's what we're going to see pretty much until the end of time. So as AC is more efficient than DC, the problem is that we can't take AC power with us. So we need the portability. So we still have to have 100 volts DC, okay, so that we can take it with us. So from here, we're going to go into our junction box. Okay. Okay. And then from here, then we're going to go into, so this is still coming out as DC voltage. Okay, it's going to come out here DC. Colors here. And so from here, then we're going to go into the inverter. Okay. So then out of our inverter, then we're going to get our three-phase AC. Okay. All right. So these are the ones here. So remember, you touch the AC, that's where you would get essentially electrocuted. If you grab a hold of the DC lines, those are where you're going to get shocked. So, okay. So inside our junction box, let's go over. Okay, so inside the junction box, we're going to have a shunt. And then here, we're going to have a contactor. Okay. So the function of the contactor is going to be, this is going to be our high voltage switch. This is the one Tony was talking about earlier that's going to act similar to a starter solenoid. It's just a coil of wire with a set of contacts in there. So if I take a coil of wire and I throw electricity to it, that's going to create a magnet. I'm going to use that magnetic field to move something. In this case, it's going to move the switch and turn the switch on and off. So that's going to allow my high voltage from the battery to then come over here to my inverter. So I need to draw in, we're also going to have a 12-volt battery. Quite that big. Okay. Sorry, I'm trying to draw quick here, 12 volts. Okay. And we'll go here. So our 12-volt battery, okay, we are going to, so we need to have, when I make this connection at the contactor, this could get a little lengthy. I'm doing it as quick as I can. Sorry, I know we're going a little bit long here. So when I make the connection at the contactor, I need there to be 100 volts on both sides. Okay, but right now there's the 100 volts that's going to the battery. Okay, so that's always right there all the time. Okay, but on this side here, there's no voltage until we make the connection. So what I need to do is I need to get voltage over to my inverter first. So inside here, we're going to have I'll draw it quickly here. Okay, so we're going to have a relay. This is a pre-charged relay. Okay, and then in here, we're going to have a switch. Just do it like that. Hopefully you can see that. Okay. So we're going to take, so essentially for the relay, we need the 12-volt battery to run the relay. So if your 12-volt battery, this is why if the 12-volt battery on your electric vehicle dies, you're not going to be able to drive the car until you jump the 12-volt battery. So I'm going to draw the short version of it here. So essentially for the relay to work, we need to get 12 volts to this relay. And there would be, so understand it's not on all the time. I get that. You can have a key switch and some stuff there, but in the interest of time here. Okay, so then, so we need to get the high voltage over here to our inverter. Okay, so what I'm going to do is so these are isolated. So we talked about we need to separate the 12-volt battery from the high voltage battery. Okay, so the coil for the relay is going to be on the 12 volt, but the load side of the relay, that's going to be on the high voltage side. Okay, so we're not mixing those. Right. So one side of this, we are going to connect to this terminal right here. That's going to put 100 volts at this side of the pre-charged relay. Then over inside the inverter, we're going to have, I'll just put here, this is going to be a pre-charged resistor. Okay, so a pre-charged resistor, so sometimes this will be inside the inverter, sometimes it'll be outside the inverter. In a Tesla, it's going to be inside the battery box. I'm going to put it inside the inverter on this particular one here. So what it's going to do is we're going to connect this side of the relay to the resistor. Then Tony had talked about inside the inverter, we're going to have some capacitors. Okay, those can, sometimes they're just 3 great big capacitors. Sometimes there'll be a bunch of smaller capacitors. So what we're going to do is we're going to send that, and we need to fill these capacitors. So we need to fill those slowly. Okay. So, and you would have, let me draw in here a key switch. Okay, so this will be a key. Okay. So when you turn the key switch, what is going to happen is we're going to close this circuit. This is going to energize, and this is going to connect this here. Okay, that is going to take the high voltage, run it through the relay, run it through the pre-charged resistor. It's going to then fill the capacitors, and then when the capacitors are full, then it is going to send high voltage that it got through here, fill the capacitors, then it's going to send it backwards down this one here. Okay, that is going to leave me with 100 volts on this side and 100 volts on this side. Okay, and then, not drawn here yet, but we need to add it in. You're going to have two control wires that are going to go from the contactor into the inverter. So when the inverter is happy with it, saw the voltage come in, filled the capacitors, it's happy, it sent the voltage back down this line here, then the inverter is going to energize this contactor, and at that point, then this will close. And so that is why when you're in an EV or a hybrid vehicle for that matter as well, when you turn the key, there's going to be a noticeable delay, and you'll hear either usually at least two clicks. And so one will be the relay clicking, and then if it has two contactors, then you'll hear each one click independently. So you'll hear one click, then the computer will run a test, then it'll do the other one. So this is just showing where there's a contact on the positive side. If the system is over 200 volts, there'll be two contactors. Okay, in this case here, I've just drawn in a shunt. We're just using the shunt. Is what we're measuring, how much current is going in and out of the battery. But it could just as easily have a shunt and a contactor in there as well. Okay, Tony, talk to me. How are we doing time-wise? How much deeper do we want to dig here?
No, that's pretty good. I guess my question would be, what are the common issues that we're seeing on EV vehicles?
Yeah, so still so battery technology has gotten very good, right? We're getting good at building batteries, but that's still going to be the weak link for sure.
Are there outfits out there that are repairing these batteries? Because everybody sees on social media about how a complete battery pack, since Tesla stands out, how it costs, over $15,000. Are there outfits out there repairing batteries?
Yeah, so there are places that are repairing batteries. So some batteries are repairable and some aren't. So the early Teslas, you could open the box. So the boxes are sealed. So we said that. So just picture you're taking a twin bed mattress out of the car, and then there's a huge lid that's sealed. So you have to pull that lid off to get to the batteries, and then when you're putting it back together, you've got to reseal that lid. So it's a little bit of a process to make all that magic happen. So on the early Teslas, you were able to change out individual modules, like what you saw in the trainer cart here. In the later ones, they are doing what's called potting the battery, which means before they put the lid on, they take a special goo and they fill the whole thing with this goo. And that's supposedly it helps with vibration and pretty much vibration. But really what it does is it keeps us from getting in there and messing with anything, as far as I can tell. But so to answer your question, you may or may not be able to repair it. The battery, or at least in California, I suppose, I don't know how many viewers are from California, but I believe it comes with a 150,000 mile warranty. So, I mean, if you get 150,000 miles out of it, it's still going to be cheaper than however much gas you would burn over that amount of mileage. So,
Okay.
other than that, I do want to show.
Oh.
Let me see if I can get it on the camera. I'm going to attempt to do another demonstration on the board here. So one of the things, and I had a couple more slides, but I think I'll just do this live here, and then we'll wrap up with any other questions. So we definitely need to make sure that this 100 volts doesn't mix with the 12 volts. And so that's what's, so if you mix these, that's what's called an isolation leak. And so that is something that we want to test for. So if I can, I want to show you that. I want to show you that process and see. So I'm going to move the camera around. You're going to see some jostling of the camera. Let's go here. Go with me just a second here. So we're able to test very easily here. Let's take a peek at the camera here. Yeah, actually that's going to work. Okay, perfect. So this section here, so this is our high voltage. This section here, this is our low voltage. Okay, so if you were nodding off, pay attention now because this is going to be an important one. So, when we're checking to see, and you're going to do this kind of regularly. Okay, so this is a 4-step process. So we want to know if the high voltage is leaking into the low voltage. Okay, so with the system on, okay, so you're hearing a buzzing noise. I don't know if it's coming through on the microphone or not. But so this is the contactor here. So that one's being duty cycled right now. So you're hearing that buzz. This was the shunt here. We're using this as the gas gauge. So I have over at this point here, so this is going to my 12-volt battery, and then this is my chassis ground. So these two are 12-volt, positive and negative, and these two here are 100-volt, positive and negative. Okay, so what I'm going to do, see if I can get the meter. I'm going to hold the meter. So I have my meter set on DC. Are you able to read the numbers on that, Tony?
Yeah, it's a little blurry, but it's still readable.
Should I try and mess with it or let it?
Just twist it one more time. Twist it. Oh, there you go. Towards the camera. No, the other way. There you actually there's good. There you go. Nope, now you're blurry.
Now we're blurry.
Right, you were there almost perfect. That's good enough. That'll work.
Okay. All right, so here we go. So I'm going to take, so with your voltmeter, so it doesn't matter which positive or negative of your leads, but so I'm going to go from the positive side of the high voltage to my 12 volt on the positive side, and then I'm going to go from the positive side of the high voltage to the chassis ground on the low voltage side. And then I'm going to do the same thing again on the ground side. I'm going to go from the high voltage ground. Actually, I'm going to change that word. We're going to call that the high voltage negatives, because the high voltage battery, it's never going to contact ground, and it's never going to contact the chassis. So unlike on the 12 volt system where you're going to have the generally you'll connect the negative side to chassis, and that will become a wire. That's not how it's going to work with the high voltage battery. With the high voltage battery, you're just going to have a single. You're going to have a wire go from the positive to whatever component directly, and you're going to have a negative wire go directly to the component. So it's not going to be ground. We're going to refer to it as high voltage negative. So what you're going to see is you're going to see voltage, and then you're going to see it quickly fall. Okay, so this is a 4-step test. So here we go. I'm going to do it this way here. So I'm touching on the high voltage, and then I'm coming over to my. Okay, so you saw it was like 21 volts. Did that come up? And then you see it falling.
Yeah, the
Tony,
voltage
were you able to see
dropping.
that?
Yeah, the voltage is dropping.
Okay. So what's happening is, so you're never going to reach true zero. Okay, so we learn in electrical, we learn about the insulators and conductors, and but in actuality, and I had a hard time kind of wrapping my head around this. Everything can conduct, even if it's an insulator. So
Right.
we're gonna see. So I'm gonna do now. So I'm on the high voltage positive, and now I'm going to the 12-volt chassis ground. Okay, and so you see it falling, and it'll never quite fall to zero. But that's okay. That's how it's supposed to work. Okay, so and then I'm going to do the same thing on the negative side. So now I'm touching over here on the high voltage negative, and I'm going to go to my 12-volt, and I have my leads reversed, so I'm getting a minus, but it still would be the same. Okay, so like there's okay. And so if I reverse my leads, the minus sign would just go away, but the numbers would be identical. Okay. And then if I go to, so if I go from high voltage negative, and now I'm going to go to my low voltage ground, and it falls. Okay. So you say, well, how would I know if I had a fault? So if you did this test and you saw voltage, okay, so like right there was 7 volts. So if it stayed at 7 volts, then you would know you had high voltage leaking into the low voltage system. Okay. So you say, well, how would I figure out what it is? Okay. Well, and that's easy enough to do as well. So what you would do, let's see if it's on camera here. Okay. So so if you had if your numbers on your meter didn't fall, what you would do is one by one you would disconnect the components that have high voltage and low voltage both in them. Okay, so in this case here, I've disconnected the charger, and then I would perform the same test, right? Where we go from my, my high voltage, check it, watch it fall. Go to the ground, check it, watch it fall. Okay, so and then so whenever you found the component that was causing the leak, then the voltage would drop. So if I disconnected the charger and I ran the test and the voltage still showed voltage here, okay, well then the problem's not in the charger. Then I would disconnect my DC-DC converter and go right down the line. Okay. All right, so hopefully that made sense. I'm going to share my screen one more time. Let's see if there was anything that I wanted to touch on. If there's any questions that come in the chat, we can address those. I see it's 10:23, so we're about on the last time. I'll be able to stay on after if anybody wants to stay on. If I've heard enough. Okay, so here's your isolation, leaks, and fault detection. So these would be all the components where you have high and low voltage close to each other, where they could be, intermixed there. Okay. All right. So Tony, you were asking on what were the problem child. So this is definitely a problem child here. So generally, manufacturers are going to have the in the dash, you'll get the orange triangle of death. And so sometimes when you have an isolation fault, sometimes it'll let you drive, and sometimes it will not, depending on the severity of it. There is, by the way, you're not going to remember the number, but there is a specification that you're allowed 500 ohms. There's 2 different specs for it actually, but you're allowed 500 ohms per volt of resistance between your high and low voltage systems. So that's how the computer figures out whether or not it's within the right tolerance or not. So this is one of my favorite pictures on the lithium battery. So lithium batteries are going to be absolutely different in the way we handle them than a regular lead acid battery. So lead acid battery, you have essentially a 12.6 volt battery, and we're going to charge it back up with 14 volts. You would never, ever, never, ever do that with a lithium battery. So a lithium battery, the individual cell voltage is 4.2 volts, and you never, ever, ever, never go over that voltage. That's when fires happen. 80% of the time that we're seeing fires, it happens during charging. And so, that's definitely something to be aware of. The other thing that's interesting with lithium is the bottom end voltage is going to be 3.3 volts for an individual cell. And when it drops below that voltage, it just dies, and you're never bringing it back. And so, so those are just two numbers that you need to know. When you remember, we're stacking these together in series. So as we take 4.2 volts, and then depending on how many of those we have in series on the Tesla, it's 96. And that is a pretty popular number, where you have 96 4.2 volt cells in series to get to your 400 volts. But yeah, so for each individual battery, and that was where I touched on the battery management system. There's a whole class just in the battery management system, but that's the component that's going to be responsible for measuring if that voltage goes above the 4.2, and will shut things down in the event that it does go above it. The other thing worth noting here is the temperature of batteries. Oops. So we have probably people from all across the country here. So the lithium batteries are kind of like human beings. And we don't like to be too cold. We don't like to be too hot. Essentially, when the battery is too cold, it doesn't really hurt the battery. It just doesn't allow it to function as well. And then whenever the battery gets too hot, that will actually degrade the battery, in addition to affecting how much electricity it can put out, how well it performs. Let's see. Okay. And then on the charging, I didn't really get into the charging, but I see we are coming up on the end of our time. Do we want to get into that, or do we want to save that for a future podcast?
We'll save it for another one. Yes.
Save it for another one. Okay. All right.
Robert is asking. He says he has 2 isolation meters. How do they check this? Is that what you're asking, Robert? You have 2 isolation meters. How do they check this? That's what Robert's asking.
Yeah. So there are. Let me get get the camera back going here. I'm gonna stop sharing my screen and go back to. Okay. So I don't know if we're back on camera there. So yes. So there are different ways of testing insulation, and so you have an insulation tester. Those are generally used to see. Generally, we're using those for measuring the windings of the motor, and to see if the electricity is leaking from the windings to the case. So that's going to be an insulation tester. You're not using that for checking an isolation fault. You're just using that to see, once you've determined that the fault is coming from the motor, then you're using the insulation tester to verify that it is indeed in the motor. So like you could disconnect the motor, and if the voltage test that I showed you, if that quits happening and the voltage drops like it's supposed to, then you can say, okay, the problem's in the motor. Then you're going to use your insulation tester to see if it's in fact the windings leaking to the case. The other, and I'm not sure which component you're using, or which tester you have there in front of you, but the other one is a megometer, and that one we're using to see not if the windings are leaking to the case, but we're using to see if the windings are shorted within the motor winding itself. And so essentially you're measuring, really in a very accurate way, you're measuring the resistance of each winding in the motor. So those are kind of your ones. So when you're doing just the basic isolation test, you're just using a voltmeter, checking for voltage between the high and low, between the high voltage and the low voltage system. If it fails that test and you determine it's in the motor, then you're going to use the insulation tester for checking leaking from the insulation to ground with the case of the motor. or the megometer for checking if the windings are shorted within themselves. So hopefully that helped.
Yep, he says thank you.
Okay.
All righty, very good. All right, anybody have any other questions here? So I guess I'll pop my face back up here.
All right.
Thank you, Mark. So as you can see, and Mark, one more question because I had one guy ask me here is so therefore you saw we talked about can sniffer and all that. So is there a scan tool that these vehicles use?
Yeah. So yeah, absolutely. Yeah, and Tesla has just released their version of the scan tool, so it's available. It's like everybody, it's a subscription. It's laptop based, and then you pay with a subscription. So Tesla charges $3,000 a year. So if you're working on Teslas, then yeah, you'll yeah. So they don't have. Let me clarify on this too. So they're not using an OBD2 port, although I'm not sure on the diesel trucks they would have a different connection anyway. So we'll just put it this way. So for the moment, uh, every manufacturer has a different way of connecting, and all of the codes are different. So
Very
but
good.
you are able to scan and get data from it. So the CAN sniffer, that's actually kind of a way of eavesdropping on the system. So
Mhm.
you're not really going through the normal channels, you're just kind of listening in. But there's a lot going on with CAN sniffing, and the guys that are really techie, they get into that. And then there's some really cool things that you can do. That's how you've heard of different like they're driving a Tesla with a game controller and different stuff like that, where you can kind of hack. You're kind of hacking into the system. Yeah, that's what you're doing.
All right, very good. All right, so since time is of essence here, we're about 2 minutes over. I just wanted to let you guys know, Mark and I are in talks right now to do some training, hands-on training. As you can see, Mark just showed you that cart. And Mark, if you want to show it to him on the camera once again, that's a trainer that he works with EV West. That's a complete system there from what he just discussed. In other words, everything you see on his whiteboard is on that cart. So one of the things we're going to be doing is, obviously, I'm going to be the basic guy. I get to have the fun part. But in this case, we're talking about doing 2 day training to 4 day training on what is electricity and electrical fundamentals, and then applying it over to the EV cart that you can see that Mark is showing you there. So in this case, the plan is to do a full electrical EV fundamental class. So in other words, from A to Z on understanding EV. Obviously, there's subsystems like any car. So there's an air conditioning system. Then you can talk about regenerative braking and so on. That's separate. But in this case, you saw Mark has his handout, his training material too as well. But again, don't think Tony's taking over this. No, it's Mark's baby. But in this case, my role here is to actually to cover the electricals that it's already set in place with our EL1, EL2 training boards. But therefore, what we're planning is doing classes. And Mark, we're talking about Vegas here. We're talking about California somewhere. So Mark, chime in on this too. And in this case, we are going to see some email blasts, and my website will be having it. So therefore, definitely help you guys out there. So if it's something that interests you, and like I said before, at the started point of all this was to get you guys acclimated with its electricity. Because, for example, just like he was talking about isolation between the low voltage and high voltage, to me it makes sense already because one of the things we teach in EL1 is what's a conductor, an insulator, and a semiconductor. And in this case, it makes sense because it's all the number of electrons on its outer orbit. So therefore, it does make sense to me. So with that said, it's something that we will be showing you and hopefully it happens. So anything you want to add, Mark, on the training that we're going to be doing?
No, yeah, I mean, you covered it pretty good there. So yeah, so we'll figure out a location, and yeah, if anybody has a suggestion, we can, actually, if there's a group, I guess we can come to your location. So,
Yep. That's another thing we're talking about too as well, coming to you. So any questions, comments? Have you learned something? Have you enjoyed this presentation? Click on the chat window, or you can unmute your microphones if you so choose. Your microphone just clicked on your name there. You should unmute. Those of you that like to leave, you're welcome to leave. We're going to be, this is being recorded. So in this case, we will be, sending a mass email out with this recording, and you could fast forward and do whatever you want to see, what you want to hear. But in this case, we'll be doing future webinars too. But in this case, we're going to be charging a little bit because let's face it, our time costs money and this platform all costs money. But don't worry, we're not going to charge you thousands of dollars on this for the webinars. So therefore, we'll be showing more about this later. So any comments, questions, but those of you that need to leave, you're welcome to leave. Mark and I will stay on here for another 5-10 minutes, and we'll call it a day. Mark, any last minute words for those that are leaving us?
Yeah, no, I just want to thank everybody for taking time out of your morning there and spending with us, or afternoon, I guess, depending on where you're at. And yeah, look forward to seeing you on another podcast. You can reach out to me if you would like at I'm at marksmechanicminute@gmail.com. So I don't know if we can put that on the chat or how we'll figure out how that works. But you can reach out to Tony. If you're welcome to email me directly. And yeah.
It's Mark's. I'm typing in right now. Mark's Mechanic.
So MarkMechanic @gmail.com.
There you go. I'm putting it up there for you guys there. There you go.
Yep, that's it. Okay, cool. No, it's a long one, but it works. So. Okay. So
any other questions?
I guess we can probably stop the recording and just freestyle questions.
Yeah, we're waiting on any questions. If anybody has, feel free to ask any questions. Those of you are staying along here. I have to get coast duties to shut this off. All righty, very good, Mr. Mark. Very good, very good. I guess we don't have too many non-questions. Oh, thank you, Gary. Yes, Gary just said thank you. All righty. Anybody have any questions? Comments, questions? Well, these guys are not chatty, are they?
They're not, yeah, that's okay. But you know what? I see we still have quite a few on. Do you want, I was thinking about just go ahead and talking on the charger for a little bit.
Go ahead.
And let me set up. So you talk for a second there while I get stuff set up over here.
All right. Nobody has any comments or questions because we're pretty much trying to help you guys out, share some information here. So Mark's going to set up a quick charging thing. And I'm trying to work this on the recording. I don't want to take away his recording, recording there. So thank you, Ronald. Appreciate the comment. Any other comments, please feel free to post them or unmute your microphone. We're pretty much allowing everybody to speak here. So
Is, I think it's so it's harder to do in virtual land than it seems. So, okay, so this is our charge port right here. So this is where we're going to connect to our wall box, and then we have the charger itself, which we said is going to be in the car, and then this is going to be our charge controller. So you're going to have so this is going to be the J1772 connector. So really this is just acting as an expensive extension cord. And we need to be able to have, when you think about over the life of the vehicle, how many times this is going to get plugged in and unplugged. So that there needs to be some durability with that as well. So, so what you're going to have here is, let's talk about the connectors here. So there's actually 5 wires in here. And so the Tesla version looks almost similar. Like I said, there's an adapter that you can change from one to the other, but they both have 5 pins. So the big pins here at the top, the 2 here, those are going to be your AC power coming in. So if you're using 110, you'll have one hot and one neutral, and then the large one on the bottom is the ground. Okay, so if you're sending in 220 volts, then they're both going to be, you're going to have 2 phases coming in on both of the top ones, and then that's part of the job of the charge controller, is it'll know if you send it to 240 volts or if you send it 120 volts. That's how it'll figure it out through those pins there. So then the other 2 smaller pins, those are going to be what's called the pilot and proximity, and those are the ones that were a little bit of a mystery to me. So when you're like right now, these are not. There's no electricity in these. Okay, so we're going to have this. It's hard to show on the camera here. I'm not sure. And I see we're still recording. Is that how you want it, Tony?
Yeah. Let's keep going. It's okay.
Okay, that's fine. So inside this box here, so this is all part of the same unit here. I don't know if it's picking up on the camera, but inside here is a contact there, or a switch. Okay, so this particular one is a level 1 charger, so it just plugs into a regular socket. Okay, like we're already familiar with. So I would plug this into a 120 volt socket. that electricity comes into this box, and then we go back to the communication lines here. So when these communication lines are happy, then inside the box we make the connection, and then the AC lines then become live. Okay, because if these were live all the time and you drop this thing in a puddle or in a snowbank or something, then you would get electrocuted, right? So that's part of the safety that's built in. So I don't know if I'm going to be able to reach. Let's see. If I have enough cord to make all the magic happen here. Okay. How's that looking? Actually, that might work. Okay. So right now, so we're plugged into AC power. So now whenever I plug into the vehicle, okay. So when I plugged in, so there's a moment there when the computer here is doing a handshake with the computer in here. So these 2 computers are talking to each other. Essentially, it's saying, "Hey, I'm here," and then it's going to say, "Oh, okay, I see you're there. Now, how much electricity would you like?" And then these are down the 2 smaller wires there. And actually, it's these two thin wires right here, the pilot and proximity. And so then it reports back and says, "Okay, I can give you 15 amps. Okay, go ahead and send it." And then once they've done that handshake, then it makes the connection in here. And then I don't know if you can see the fan, that the fan is spinning here, and we're charging. And so in this case here too, I'm not going to be able to get close enough to the camera. So I'm charging this one at 11 amps. Is that coming through on the camera or not?
Yeah.
Yeah, so you can barely see the 11 amps. This is where let me show the amp clamp. See if that's going to fall on the So this is where I absolutely love this meter. And We're going to set it to amps. Okay. It's going to be on the camera. So we're on amps. We do need to make sure that we're on DC. Well, they're depending. And actually, I'm going to do it on both of them right now. So I'm going to check the AC line. So you have to push this select button, and then that changes it over to AC. And then this will show. That's going to actually. So then I can just come around my line here, and I can see. So I'm charging at 10.93. Is that coming through the camera, Tony?
Yes, sir.
So 10.93 on the amp clamp, and then on my wall box is showing 11 amps. So that's, you know, basically they're both showing the same. And then we can, and this is part of what we'll get into in the detail during the classes. So you have the AC amperage, but then you also have DC amperage, which depending on the voltage that you're working with, it's going to be much different, right? So in this case here, this is a 100-volt system. So the AC is 120 volts, so they're almost identical. But if you're working on a 400-volt system, the amperage coming out is going to be so on a higher voltage system, the amperage coming out is going to be much lower, right? Which is kind of opposite thinking. I don't know if I can do the camera. Let's see. I'm trying to do a little more camera work here. This thing got a camera view. I see. Are we showing that we still have? Is there 45 still on? Oh, that's in the chat. 22 still on. Okay. Okay. So on this, so in my charger, I came in with AC, and then I'm coming out DC. So I need to change from AC to DC. And so then this is going to be my DC coming out. And I see here, we're running at about 12.81 DC coming out. And that's so the reason that it's higher on this one is so we have the AC coming in is 120 volts, but the DC coming out on this one is 100 volts. So because we went down in voltage, we went up in current. That's why my DC current coming out is about 13.5 amps versus on the AC side, it was 11 amps. Right. So if you were on if we were charging a 400-volt battery, then the amperage coming out here would be much lower. So it would be like you'd be charging like 5 amps. So that's where you can, you know, so when you're charging 220, if you're charging 220 volts and you're charging 80 amps, the actual amperage going into the battery would be somewhere around 40 amps going into the battery, which is still pretty substantial. So, yeah, so I guess that kind of, so I guess we should touch on the level 1. I didn't really get into the level 1, 2, and 3 deal. Let's see if I can swing back over here. That's making everybody dizzy. Okay, so this one here, because I'm connected to 120 volts, this is a level 1 charger. Level 2 charger would be if I was connected to 240 volts. So I'd be sending voltage down both of the lines in the plug here. And then the other option is you have level 3, or what is called DC fast charging. So for DC fast charging, we are actually not using an onboard charger. We are actually this is level 3 only DC fast charging. The charge station is on location, not in the car. And so the way they do that is they use a second set of contactors where they actually disconnect this charger from the circuit, and then they connect the lines to the plug directly to the charger. And so you're just sending 400 volts straight into the battery at that point. So so that's your level 3. So with that, yeah. Any more chat questions come in the chat? I see we still have 22, 21.
You got one yeah, you got one chat there. I'm trying to get to it. Oh dear, hold on. I just got another window over my window. You did have a chat, and that is from Robert Hillstrom. He's saying, I'm assuming like a hybrid, it is a few and far times that the HV battery goes dead. Is the Tesla battery like a Toyota hybrid battery where you can replace individual cells?
Right. So I'll say, as far as Tesla, up until about 2021, you can open the box and change out. So let's talk about, so a cell would be like a AA battery is a cell. So that's an individual cell. So they connect those individual cells together to create modules. So you're not going to be able to get an individual cell out, but you will be able to take an individual module out. So in 2021, they started podding the battery, so you're not able to get an individual module out without like destroying the pack. But up until 2021, yes, you can change out an individual module. One thing that you need to be aware of is, so this audience should be familiar with changing out diesel injectors. And just like how the diesel injectors, how they're balanced, we either calibrate them or we have a matched set. If you change out just one module that's not part of the original family and it's not balanced, then the computer would have a hard time keeping it in balance, and you could end up with a code for being out of balance. And that same thing happens on like the Toyota Prius. That's a popular one. You can swap out an individual. So in the Prius, I like to think of the Prius battery as a loaf of bread, and you just have the individual slices. You can take one slice out and put it in a new slice, but if they weren't close enough to a matched set, then the computer it'll never keep it. It'll never be able to keep it in balance.
Okay.
So that's why often it is more successful to just change out the whole pack. But I mean, for me, like I'm gonna try.
Very good. All righty. Thank you, sir. I'm going to go ahead and, well, any other questions, guys? Because obviously Mark and I have to get going here, but let me reclaim. Any other questions? Yes, you're very welcome, Mr. Joe. Mr. Joe says, thanks to everybody. Thanks, fellas. Very good. And yeah, I mean, we're doing good. Any other comments? Questions? Well, like I said, Mark's going to be available. Obviously, if you have any questions with me, y'all got my mass email. You're welcome to contact me too as well. But any other comments or questions are all welcome right now. But Mark, what do you say we call it?
I think, yeah. So if anybody is welcome to, I don't know if I'll get on camera here again without changing everything around. But yeah, you're totally welcome to email us or watch for an email on a future episode.
Good.